And the way we set it up was we did the following things. We drew the principal axis, which is a straight line across the paper. We drew a picture of the mirror. We drew a vertical line that went all the way across from top to bottom. And then we put F, O, and C. And if you remember, F is the focal length. It told us in the problem. The problem said the focal length is 3. So we measured 3 from the mirror. Then it said O was the object. It said it's 2 centimeters tall and 5 centimeters in front of the mirror. So we made it 2 centimeters tall and 5 centimeters away. And then the last thing is C, and C is always double F. So F was 3, so C was 6. And we're using our straight edges and our measurements to do that. So I'm using centimeters. So I measured out, here's 80. So I would measure to 77, and that's where I put F. And then I measured from 77 to 74, and that's where I put C. And from 80 to 75, that's where O would be. So I'm being very deliberate with the drawing. So make sure you measure things. Okay, don't just draw them. Because that's what you're going to be tempted to do. You're going to be tempted to just draw them. Don't draw them. Got to measure them. Okay? All right. Step 1. Set it up. Step 2. So, draw a line from the top of I don't know why the F is so far away, of the object. So you're going to draw a line from the top of the object straight to the mirror. And you're going to reflect it through F. So you're going to draw a line from the top of the object. You're going to draw it straight to the mirror. And then you're going to reflect it through F. So what does that look like? Now, I'm going to do mine in Purdy colors. You can do it in Purdy colors, or you'll see I also do dashed lines to show the reflection. You want to be able to tell the difference between the reflection and the regular lines. So here's how I do it. I'm going to draw a straight line from the object to the mirror. Now I'm actually going to that vertical line. I'm not really going to the mirror. I'm actually going to that vertical line. Just like that. And then you reflect it through F. Now, I like to use a different color. That's completely up to you. I do suggest doing dashed lines, though. And you're going to reflect it through F. Now you'll notice I went backwards too. We don't know where the image is going to form, so we go ahead and draw it coming back from the mirror, but we also draw where it looks like it came from. It looks like it came from inside the mirror. Okay, so there's your first line. Straight to the mirror, through F. Okay, that's line 1. Okay. Okay, line 2. So step 3, line 2. Draw a line from the top of the object. Draw a line from top. Okay, same old, same old. Draw a line from the top of the object. It's going to go through F to the mirror. and it's going to reflect straight. And what I mean by straight is parallel to the principal axis. The principal axis is this flat line. So it's going to reflect parallel to that. So it's going to go from the top of the object through F to the mirror, reflect straight. If you're saying to yourself, isn't that the exact opposite of what we just did? Yeah, it is. It's the exact opposite of what we just did. So let's do the exact opposite of what we just did. We're going to go straight through F to the mirror. And again, we're really going to that vertical line. We're not really going to the mirror. We're going to that vertical line. And then it reflects straight, which is parallel to the principal axis. Okay, so now we draw straight back. Do it as straight as you can. It's not going to be perfect. But nobody is. That was not too bad. Okay. Draw a line. Blah, 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 from the top of the object. Blah, 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 blah. That connects C to the mirror, and then it reflects back on itself. This one is the easiest to draw, but it's also the most confusing. It goes straight through C to the mirror, and then straight back the way it came. But you have to line it up with the object. You got to line it up so that the object, the mirror, and the C are all connected together. So it's going to look like this. So connect C, O, and the mirror. You're going to notice that mine's not going to actually connect. So I just line up C and O, and I send it towards the mirror direction. Mine's not actually going to reach because it's going to go off the paper. And that's fine. But then it reflects directly back the way it came. So I'm going to draw it straight back the way it came. So this one's the easiest one. You line up O and C and send it towards the mirror, and then you reflect it straight back. So the problem says, draw the diagram and find the image location, size, and type. So we're going to use the drawing to answer those three things. We need to know the image size, which is, or the image location, which is DI. We need the image size, which is HI. And we need the image type, which I just call IT. Okay. You're saying to yourself, Mr. B, I have no clue. Like, I got line. What am I supposed to do? Here's what you do. Where do the lines intersect? Specifically, the reflection lines. Where do they intersect? Right there. Whack. See how they all meet there? Yours don't. Now, if yours don't intersect, do they make a triangle? Do they make a triangle? They make a triangle, make a triangle. Okay, triangles are good. It's obviously not as good as mine. But triangles are fine. Okay, triangles are fine. Put a dot where they intersect. Or put it in the middle of your triangle. Put a dot there. Okay? And then what you're going to do is you're going to draw a line, because we haven't drawn enough yet, from the axis to that dot. Just a straight line from the axis to the dot. And make it an arrow, because that's your image. That's your image. See, we drew the top of the object, so what we got is the top of the image. So if the top of the object was an arrow, then the top of the image is an arrow. So if you're drawing a yak, which I think is problem number 1, it's drawing a yak, you would draw the yak head down here. Now, I would suggest just using arrows instead of drawing yaks, but if you're like a huge yak fan, then good for you. Okay? Now you're saying to yourself, sweet, I got an arrow, what do I do? DI, how far away is the image from the mirror? Literally, just measure it. Okay? 75 is where I put the mirror. 68 is where my image is. A lot of people ask me, what should I round to? What if it's not exactly, so mine is exactly 7 centimeters. What if mine's not exactly 7 centimeters? Round to the nearest quarter. Round to the nearest quarter. So if yours is halfway between 68 and 69, or so that would be halfway between 6 and 7 centimeters, you'd call it 6.5. If it's halfway between halfway, then you call it 6 1/4 or 7 or 6 3/4, whatever. But estimate it as best you can. But I got mine. Mine's exactly 7 centimeters. In 5th period when I did it, mine was 7 1/4. You don't have to get exactly right to be right. You have to get reasonably close, right? If you got 15, it's not great. It's not good. But if you got like 8, and I saw your diagram and your diagram's right, I'm fine with 8. If you got, yeah. Do your lines look like mine?
I have a triangle, but yeah.
Okay, a big triangle?
No, it's really small.
Okay, all right. Yeah, as long as your lines kind of match up the way I drew mine. I can double check yours, but yeah, it's probably fine. Okay? Then you're going to measure the height of the image. So I'm going to measure here. I'm going to start at 80. Nope, I'm going to start at 85. And I get, what do I get here? 2 1/4. No, 3 1/4. Nope, 2 1/4. 2 3/4. Okay, I can measure. Woohoo! So I got 2.75 for the height of my image. Actually, it's negative 2.75. It's underneath. It's not above. It's underneath. So it's negative 2.75. So all that's left is to decide, is it real or is it virtual? Those are the 2 types of images. It's super easy to figure it out. Super easy. Where does the light actually go? It actually bounces off the mirror. It doesn't go through the mirror. This is just where it looks like it came from. Where it looks like it came from doesn't actually go back there. Where did the light meet? Does it meet where it actually can go, or does it meet where it actually can't go? It meets where it actually can. So it's real. And that's the problem. That's it. You draw the 3 lines, you find when they intersect, you draw the image, you measure the stuff. That's it. That's the problem. Okay?